Hey everyone, welcome back to the course. So in the last lecture we discussed about the introduction to Hyperledger Fabric, and we also went through different functionalities which are offered by Hyperledger Fabric. In this lecture we are going to discuss about the Hyperledger Fabric key features, and these are the key features that makes up the whole Hyperledger Fabric network and constitutes an important part of the blockchain ecosystem under Hyperledger Fabric. So to define the key features, Hyperledger outlines its key features in following sets: assets, chain code, ledger features, privacy, which is provided with channels, security and membership services, and consensus. So let's go into the each feature step by step and understand what each feature provides. So the first one is assets. Assets inside Hyperledger Fabric is a collection of key value pairs. Assets can be defined as a tangible or an intangible thing. It could be that you can define assets as hard drives or USB disk drives, or it could be the intangible objects such as contracts. Hyperledger Fabric provides you with the solution of creating these assets using the chain code and Hyperledger Composer tool. Moreover, each asset in Hyperledger will be represented either in a binary format or a JSON format. Every transaction which is happening on top of the Hyperledger Fabric network could be related to the modification and updation of these assets. The next key features Hyperledger provides is with the chain code. Inside Hyperledger Fabric network, everything runs through chain code. Any kind of update you want to perform on top of the ledger has to go through chain code. You cannot directly update the ledger itself. You need to have a chain code running on top of the client or a peer through which the user will interact with the blockchain ledger. Chain code is nothing but another name for the smart contracts in Hyperledger. We can define our business logic or different calculations and algorithms over the chain code, which we can utilize inside the Hyperledger blockchain network. Inside Hyperledger Fabric network, chain code must be installed on each peer. A role of the peer is defined using the chain code. There are multiple roles inside Hyperledger Fabric which we will see in detail in the future lectures, but each role has to be defined for a peer using the chain code itself. Chain code can have multiple policies. They can allow different users to perform some functions and some other group of users to perform a different set of functions. Inside Hyperledger Fabric, chain codes are of two types. The first one is the developed chain codes, which are written in Go, Node.js or Java programming languages, and they are deployed over the network to perform a specific operation or a project. The second one is the system chain code, which is the core of the Hyperledger, and they help you to manage the blockchain network for installing, instantiating or updating the network entities. The next key feature is related to the ledger. The ledger inside Hyperledger Fabric is a sequenced, tamper-resistant record of all transactions. Ledger inside Hyperledger Fabric records the state transitions of the assets which are the results of chain code invocations submitted by the users. So in a layman term, we can say a ledger is a key value storage where we store the assets, and then any transaction which is happening inside the network will actually transition the state of the asset from one point to another. So let's say you are working in an agriculture industry. In the morning, you started a chain code which defined that you have 1000 apples. Throughout the day, you will keep on selling those apples. So you will keep on doing the transactions. Your initial state is 1000 apples. Your state with the first transaction modified to 950 apples because you sold off 50 apples, and those 50 apples are recorded as a transaction. So each transaction which is resultant of a chain code submitted by the user which update the state on top of the ledger. As we have already discussed, Hyperledger provides you with the functionality of channel, and every channel maintains a separate ledger. Every channel stores the permanent sequence record of blocks as per they are constituted by the state of the ledger. Moreover, each peer keeps a copy of the ledger for each channel which they are part of. For example, let's say you are working in an hospital industry and you have two departments which have two channels separated by their functionality. So you have a channel 1 related to dental and a channel 2 related to cardiology. Now dental channel will have its own ledger and cardiology channel will also have its own ledger. Let's say there is Dr. 1 who is only part of dental channel. So Dr. 1 as a peer will only have the ledger for the dental channel. Now let's say there is a Dr. 2 who is part of your cardiology channel. So Dr. 2 as a peer will only have the ledger of the cardiology channel. Now let's say there is a peer which is a nurse 1. This nurse 1 is a participant for both the channel. Nurse 1 has the access to the dental channel and also the cardiology channel. So nurse 1 as a peer will actually store both the copy of the ledger at their end. Nurse 1 will have a copy of the dental ledger and also have the copy of the cardiology ledger. So in this way, ledger is stored at the peer level. Some of the key points about ledger. Inside the ledger, transactions are ordered in blocks. Moreover, transaction consists of versions which are key value pairs for reading and writing into the chain codes. Peers who are part of the network validate the transactions through some policies and enforce the rules. A channel who is running a ledger will define its own policies, access control list, and other pertinent information. So a channel can have its own permissions, authorization, and authentication set, which will allow the participants to access the data on top of that channel. Mostly ledgers have a query-based approach where we can look up the data on top of the ledger using key value-based lookups, range queries, or vital composite queries. So that was about the ledgers. Now let's talk about the privacy, which is another key features for the Hyperledger Fabric. Hyperledger Fabric offers the privacy through channels. As we have discussed in the ledger itself, channels are similar to a private network or a private ledger which can hold two or more members to conduct a private and confidential transactions. Hyperledger Fabric employs one single ledger per channel. Moreover, chain codes can be available specific to the channel. So again, going back to our hospital example, you can have some chain codes which are only running on dental channel and some other chain codes which might only be running for the cardiology channel. The ledger which is existing on the channel is only in the scope of the channel. You cannot access that ledger inside the other channel. So for example, if you have a dental channel, you cannot access the dental ledger inside the cardiology channel. Moreover, participants can connect to one or more channels and accordingly they will store the ledger at their end. Although channel provides you with the privacy between the users and participants, you can still further obfuscate the data by encrypting the data before putting up on the channel. Finally, channel provides fabrication of assets and participants over the Fabric network. Now let's discuss one more key feature for Hyperledger, which is security and membership services. So now we know that Hyperledger Fabric governs the participants with their identities. These identities are generated through the trusted membership service provider. This trusted membership service provider is very similar to Active Directory or Certificate Authority, which utilizes a public key infrastructure to generate the certificates and tie those certificates to organization, network components, and users or applications. This also helps us to manipulate and govern the whole network because now we have the approach of certificates. So we can provide the access control, we can provide the permissions on what each participant, what each peer can do inside the network. Moreover, we can also maintain the privacy and confidentiality. Let's say me and you are part of a network. I am doing a transaction who is only going to be accessed by you. So I have a certificate at my end generated from a membership service provider, and you also have a certificate at your end which is generated through the membership service provider. So both the certificates which are held by you and me will actually help us to manipulate and govern the capabilities and the permissions which we can do and which we can perform over the network. So in a way, we can say that the privacy and confidentiality can be maintained by combining both the channels and the membership services over the Hyperledger Fabric network. The last one is the consensus. The consensus in the Hyperledger Fabric network is followed as a practical Byzantine fault tolerance. The consensus ensure that the whole network is validated and the whole network is working according to the policies and according to the rules and regulations which we have specified for the network. There are certain operations performed by the consensus inside Hyperledger Fabric. So one of the key features performed by the consensus is that it maintains the correctness of all the transactions inside the proposed block. It verifies that the transactions are being followed as per the endorsement policies, as per the consensus policies. Moreover, it also agrees on the order and the correctness on the results of the execution of the transactions. So let's say currently I have 1000 tokens for apples. A new transaction came in which reduces my tokens by 100. Now my new state is 900. So consensus will maintain that the results of execution is correct with the transaction or not. Finally, it also interfaces and provides a layer of verification and correctness on top of the transactions and blocks. So these three are the major things which are done with the Hyperledger Fabric while we are working with the consensus. There are two different kinds of models of consensus inside Hyperledger. One is a permission voting based, which is very similar to how Bitcoin is working, where you have multitude of nodes and they provide a vote on top of a transaction whether this transaction is valid or not. Let's say you have 10 nodes inside the complete network and a new transaction comes in. Then these 10 nodes provide a voting percentage that whether everything is working fine or not. Once we have received 2 by 3 of the votes, then everything is being updated and the new transaction is committed over the blockchain. And the second one is a lottery based consensus where we do a round robin approach and then check the transactions through a kind of a random process where we provide the transaction details to some of the peers and they verify the results and give us back the feedback or the flags which are provided in the Hyperledger Fabric. So we will learn about consensus in the later sessions and see how all the details are structured with the consensus on top of Hyperledger Fabric. So that was about some of the key features about Hyperledger Fabric. In the next lecture, we are going to go through the overview of transaction flow in Hyperledger Fabric. This transaction flow is important for understanding the concepts of transactions for Hyperledger Composer 2. If you have any queries, feel free to contact us at info@v2blocks.com. Thank you.